In this video, you are going to learn how to compute descriptive statistics when you're analyzing a test that you've administered and then scored. First, remember that we use sources from the internet to make this code and to learn how to make it as good as it can be. So remember to consult these citations that we used and this really helpful code that's around that we use directly to make this. The data that you're about to see aren't real and are for educational purposes only, so they should not inform your opinion about the subject matter. First, we're going to start by loading some packages that'll help us compute descriptive statistics. And then I'm going to find the file that we're going to use today. And here's our test data. And we're going to look at the data. So imagine that I administered a test and had students in the class fill out a questionnaire about their background. For example, what age they were when they started communicating in English, how many months they've spent communicating in English, etc. And then I gave them a test with a bunch of different items, and then I scored those items. So 0 means they got the item incorrect, and 1 means they got it correct. And imagine that I also administered a speaking test. And although there are a lot of variables here, you'll learn more about what these variables mean in later videos. Today, we're just going to focus on the average speaking scores and the total scores for the multiple choice section here. Total scores for multiple choice, these are the multiple choice items, and the average speaking score. So first, we're going to compute a general overview of the descriptive statistics for the multiple choice section. So first, I got the multiple choice total, and then I ran this function on the vector that is the total scores. And then I run that function to get the mode, which is not included. I encourage you to use skewness and kurtosis from this package instead of this package here. So we're going to run those again. These skewness and kurtosis values match the outputs from SPSS and are called type 2. And we're going to do the same thing for the speaking section. So we can sort of look through this quickly and see that for the multiple choice, we can see the maximum, minimum, mean, median. We have our mode, skewness, and kurtosis, and the same values for our speaking test. And then to visualize the distribution of our data, we can make some histograms. Here's a histogram for the total multiple choice scores, number correct, and the frequency, as well as the same type of histogram for the speaking scores.